is a really good graph. I put the blockchain on the center, and around blockchain, there are bunch of different technologies and terms, such as decentralized finance, NFT, virtual reality, metaverse, cybersecurity, decentralized autonomous organization, scaling, autonomous systems, 5G, Internet of Things, Web3, oracles, AI, big data. And those are, some of them are technologies and some of them are terms around blockchain. And if you look at you'll see the markets, industry markets like energy, like payment, jobs, education, real estate, governance, like e-commerce, manufacturing, smart houses, ecosystems, insurance, crowdfunding. I put for instance, society close to NFT because that's the most related one, right? I put the future of work or governance close to DAO because they are the most related to DAO. And I'm sure there will be more industries coming around this thing, but it's a huge technology because it's changing the way companies do business, right? It's a totally new way, totally new infrastructure. So we call this disruption, like Tesla is a disruption, right? Totally changed how cars drive. And iPhone was a disruption, right? Like totally changed the way the life goes on. So blockchain is also a huge digital disruption, and we are still at the early ages of.
I have a question. How is big data related to blockchain?
How is big data related to blockchain? Well, great question. Data is the gold, right? Like all the companies are behind your data. So, and also oracles will be the data provider. So when companies data from your cell phone, they get data from web, right? And all those data with AI, they get meaningful shape. Like you heard the company Insider, right? They just became unicorn last week.
Yeah, yeah.
So it's a data company, and that's why they are valuable, because they are getting meaningful information from data. Like for instance, if I know the age of people, and if I know those people, the like probability that they click a link, right, I can estimate basically the profits that I'm getting from an advertisement. So that's a big data example. So why blockchain on big data? Well, because blockchain is a trust mechanism. So companies cannot really rely on where the data comes these days. Like a hacker can just go to a system and provide like malicious data, right? Like a lot of data, but which are wrong. This is called adversarial attack. They mimic like a data, like a lot of important data. It goes to the AI system, and AI system gets confused and they don't even understand. And basically the entire system gives wrong result because of not knowing where the data is coming. So basically blockchain being a trust mechanism, it will confirm where the data comes from, right? So every data will have a signature behind it. For instance, you are driving an autonomous, not you are driving, but you are sitting inside an autonomous car, and there are a lot of Internet of devices, and your autonomous car had an accident. And that data, the accident data, needs to go to insurance company. But insurance company needs to know that data is reliable, right? Like how will it make sure that that accident data doesn't come from a different source? IoT device, which is an identity now, like every IoT device will be basically an entity. Insurance company will know that, hey, this data is written by this IoT entity and it is basically secured on the blockchain, so we trust. Let's just start with Bitcoin as a means of money transfer, right? So everybody knew about it, but not blockchain. So Bitcoin is a blockchain protocol. Just like me, you, somebody opens a Bitcoin wallet and sends some kind of, they want to send some kind of money asset to someone else. That someone else has an address, just like a mailing address. It is a wallet address, a digital wallet. So Rob gets that address of Laura, put it in his wallet, digital wallet, and puts the amount they want to send, he wants to send to Laura, and basically fills the amount. There is a fee because this amount is sent through a protocol, like a platform. So platform providers needs to get that fee, right? Of course, there is a fee. And then the amount is sent. So this is the user part. Basically, this is the user interface, the wallet side. And at the background, when this is a transaction, this transaction goes through the machines. Like there are a bunch of computers. And just before it goes through the machines, the wallet, such as MetaMask, it signs a transaction and makes sure that Rob's key, everybody has a private key with their wallets. And the wallet makes sure that the transaction matches Rob's private key, and Rob has actually the entire amount in his wallet, right? Two things. The money is there and he's actually Rob. So then after that, the transaction goes through the machine and it's propagated to a bunch of different nodes. So a bunch of different nodes mean, as you can see, when a transaction is gone to a computer network, it goes through one of the networks and it's just like a virus spreads. And this protocol is gossip protocol. There are some other protocols and it is gone. And all these nodes are aware of the transaction. So transaction is propagated and it's also validated by the network nodes. And then after that, other than these networks nodes, there are some miners. So miners are the ones who fight to verify this transaction. And the way that they verify this transaction protocol, SA26, a cryptographic protocol, right? And these miners basically try to solve a computation, and it's called nonce. The miner, first miner who solves that computation, that cryptographic game, adds it to the block. And this is called proof of work. All these miners compete to solve the hash, to solve the nonce. And then one of them, whoever does it first, creates the block and adds it to the blockchain and gets the rewards from the system. Like basically they get Bitcoin. They are not doing it for free, right? They are validating a transaction and in return, they are getting their reward. So this reward mechanism done through the computers, like a lot of different computers competing, and also a lot of different validator nodes verifying, makes the blockchain a decentralized system, right? So it's not like there is one commander and commands everything. There are a bunch of nodes, they verify the transaction. There are a bunch of miners, they compete to solve the puzzle. And then eventually, after the puzzle is done, it goes back to all the nodes, like a virus again. The nodes verify the results, and then Laura got the money, right? But this is how Bitcoin works. As you can see, there are different protocols. Like, what do I mean with different protocols? Just like Bitcoin is a protocol, Solana is a protocol. It's another company. Ethereum is a protocol. What is this one? Ethereum 2.0 is a new fork, a new different way that Ethereum does things. Basically, it's a fork. Binance, Cardano, Polkadot, Cosmos, Avalanche, Phantom. These are all layer one. They are basically the biggest protocols that does the business, just like that has all those validator nodes. And on top of these protocols, there are other companies building their company on these protocols. So as you can see, a Bitcoin transaction per second is like 7, but like Solana is 65,000, right? Like for instance, Avalanche is 4,500. So these compete with each other to get the market, because the way that they want to be on the market is by getting the market companies, right? Basically layer 2 companies. They want them, hey, come and build your system on our protocol, like DeFi, NFT, DAO, like anything you can imagine. Basically, these are the providers, protocol providers, and all other companies put their startups, the protocols on these layer ones. We'll go through what these are later, but this is just for you to get a general idea. So I talked about this a little bit. I'll skip this. So what are the properties of the blockchain? There are like 5-6 very important properties of blockchain that made blockchain world famous right now, right? So programmable, secure, anonymous, unanimous, distributed, immutable, and times. So I'll go through some of them quickly. Distributed, what is distributed? Well, if there's only one commander, one king, and he dies, the entire system goes, right? So in decentralized, well, there are different departments. One of the head of the department is gone, that department is gone, right? But in the distributed, just like Bitcoin nodes, if one of the nodes doesn't work, well, the other nodes make sure the system works, right? Because there are so many of them, like a web. And that's why these Bitcoin and similar protocols on the blockchain, it is a very secure system. It cannot be hacked. It cannot be deceived, right? But is really Bitcoin decentralized? Another story. Well, because the way that Bitcoin works is there is a consensus mechanism, like which means there are a lot of nodes, and let's say there are 100 nodes. If 51% say thumbs up and 49% says thumbs down, well, 51% win, right? So basically, if an enormously rich person gets 51% of the Bitcoin node, like computers, and basically wants to deceive the system, can it be done? It can be done. But is it easy? No, it is very, very, very hard thing to do, right? So similar to other companies like which are doing proof of stake consensus, which I will come shortly, it's the same problem. So what is immutable? Immutable means a thing written on the blockchain cannot be changed. So what does cannot be changed mean? Well, let's say you write something, you made a transaction is put on the blockchain, and like bunch of other transactions. And every block has a timestamp, and it is actually linked to the previous block's hash. Hash is basically like bunch of numbers. It's like an identity, you can think of that block. So to hack into this block, basically you need to go to this block. To get into this block, you need to go to the previous block. And eventually you need to go up to Genesis block, which is the first block created in Bitcoin. So that's why it is almost impossible to change the data on the Bitcoin protocol or any other blockchain protocol designed similar. Is it secure? We talked about this. It's very secure because there's a cryptography behind it, very decentralized, a distributed system. And if the consensus mechanism is a powerful consensus mechanism, it is a very secure. Is it anonymous? Well, some people say it is anonymous, but a lot of argument is behind it. You have a wallet address, right? And if that wallet address is known, that it belongs to you, and government can figure out who made the transaction is you. Like, so for instance, you hacked Coinbase, right? And when you hacked Coinbase, you send all those amounts, cryptocurrency monies to an address. And if that address is actually in a address on the web, because there are a lot of companies that basically links people to the blockchain addresses these days. So it's just like white pages, right? I know your name, I know where you live, I know your phone. It's not really anonymous because even the hackers are found and then brought to the court, right? So there are some cryptocurrencies which are specialized in making it anonymous, but I wouldn't say it's anonymous. The biggest risk of blockchain is, and in case a conflict happens in the blockchain, it's very hard to solve it because everything is autonomy. Like I sent money to Yarkın through blockchain. Yarkın got my money, and I said, "Hey Yarkın, I sent it wrong. I wasn't supposed to send you that much." Well, there is no way to turn it back because once it is written, right? And if Yarkın doesn't send it back to you, well, will you go to the court? And which court will really take it as a case? Because there is no jurisdiction, right? Which court will you go? Like, where is this thing happen? Did it happen in Turkey? But really, does a Turkey court look into this? How do they know it's me? How do they know it's Yarkın? Like, right? There are a lot of basically issues that is still very vague, and it is the law is coming from behind, which is really bad. There is a lot of regulation problems still even in US, and that's why because law is coming behind, technology is not able to leap very fast, right? It's always kind of locked how law shaped at the background. So, and there are a bunch of other issues like security issues and like basically development issues. What if a smart contract is written with flaws, right? A lot of hacks happening. They are basically abusing these smart contracts. Some of them are like basically giving the hack money back, but like white hackers. But still, it is a very new area like that's entire blockchain market. So anonymous means basically the consensus. Every blockchain protocol has a consensus mechanism behind. Like Bitcoin has proof of work. Ethereum too came with proof of stake, right? Proof of activity means between proof of work and proof of stake, a mix of it. And all these different blockchain companies come with a proof of something, right? Some of you heard Helium. Helium is proof of coverage, like Cardano, proof of stake. For instance, what other companies have what kind of proofs? Like those ones who are trading. Are you trading knowing the company? And these are the blockchain layers. The bottom layer is hardware layer, and the hardware layer like Bitcoin protocol, right? How those nodes work, how those nodes talk to each other, how miners verify the transaction. And at the top of that layer, it is the digital ledger public platform and data platform. Basically, these two layers, which we call it network layers and protocol layers, are how consensus mechanisms are built. There are side chains, like there are oracles in the top of the protocol layers. And at the very top layers, dApps, right? It's called application layers, which are building their companies, like basically the protocol layer, like Ethereum. Ethereum is a very valuable cryptocurrency and blockchain protocol. Well, Bitcoin is used to transfer mostly monetary assets, right? I send money from myself to somebody else's wallet. Now, after Bitcoin protocol, somebody called Vitalik, a Russian Canadian guy, came up with Ethereum and said that, well, instead of doing only money transfer, why don't we do any asset transfer? Why don't I transfer data? Why don't I transfer identity? Why don't I transfer a land ownership certificate, right? Like transfer means basically writing the ownership on the blockchain. And he came up with, not just he came up, like somebody in 1995, Nick Szabadzo, came with the smart contract proposal, but he basically developed the smart contract, basically all this idea way further, and came with the company, like an open source company called Ethereum. This Ethereum protocol is basically an open source protocol. A lot of different developers improve the protocol day by day, and it has a lot of basically disadvantages like a fee, right? Because the Ethereum protocol has a lot of fees when you send an asset to someone else. Because of the consensus mechanism, it charges you gas, and that's gas fees through ERC20 basically. And although it is very expensive because it was first time to market way before the other companies, it is widely built right now in the world. So being time to market is very important. That's why, because although it's very like 5 times, 10 times more expensive, people are still preferring Ethereum because it has a much bigger audience, right? There are many companies who build their companies on Ethereum protocol. A smart contract is programmable, and basically you write a programmable contract using a language like Solidity, and through that contract you can do transactions on the protocol. And I talked about MetaMask. If you don't have a MetaMask yet, go to the MetaMask, though I don't really know how decentralized it is right now. I just heard some news that people in Venezuela couldn't reach their MetaMask. I don't know if it is still the case, but there are a lot of wallets similar to MetaMask, and you do the transaction using those wallets, which are not in Binance, which are not in Coinbase, right? It is basically a Web3 wallet that you own. So I'll skip these ones.
Hocam, before that, can I ask a question?
Yeah.
Is there any other protocols like Ethereum that provide APIs to program smart contracts?
Yeah, definitely. Like these ones are the biggest smart contract like protocols.
Do they have their own program language, or they depend on well-known programming languages?
I believe mostly are written which prefers Solidity. But Muratan, do you have any say on that?
Yeah, if it's not an EVM, it's not a Ethereum virtual machine. Most of the time you need another programming language. Over here, Ethereum, Binance Smart Chain, Cardano. I'm not quite sure about Cardano. Avalanche, Phantom, they're both can be written by Solidity and Viper. But in Rust, Solana, you need to know about Rust. So as long as it's the same machine, you can use the same programming language, basically.
The machine that Muratan is mentioning, it's called EVM, right? It's a virtual machine, Ethereum virtual machine. So the codes that is written, the smart contracts, it goes like to assembly language, like compiled. And after the compiled, eventually it turns to a machine code, right? And that machine is, for instance, for Ethereum, it's EVM. Like everything is eventually ones and zeros, right? Basically, Ethereum has EVM, and other protocols, they not necessarily have like a virtual machine like EVM, but they have some other protocols. We will learn how to write a smart contract in this module, not like basically through the semester until the end of May. So why a smart contract is important? Well, because smart contract fix the world, right? How does it fix the world? Well, you got a flight. It's a very important meeting you need to catch, and flight doesn't come. It's postponed, and you are so angry. You want to get your money back, and you want to sue the company, right? You write them and they never get back. Similarly, there are a lot of cases like that. Something happens and there is always a subjectivity behind it. So in a smart contract case, there is a code written that is autonomously implemented and executed. Basically, everything, all the conditions, if clauses are written one by one. So a law contract on the paper or digital is basically written on the Solidity and implemented on the actual protocol or platform. For instance, you buy the flight, you pay extra blockchain premium, like a smart contract premium for this case, right? Insurance premium. And insurance smart contract got your flight details. Basically, when you bought the tickets, everything is assigned there on the blockchain protocol. When the flight is delayed, there needs to be a sensor, right? That detects that, hey, flight is delayed. And this sensor should be also a decentralized sensor. And hacker just can go there and say, hey, flight is delayed. So even the oracle should be decentralized. The data should come from different nodes to the contract. So that's why oracles are as important as blockchain protocols. But Oracle provides it as a smart contract, and that data automatically triggers it. And hey, if it is delayed, I automatically get my money without even discussing with anyone, right? And if it is not delayed, I don't get the money. So that's why this autonomous structure of the smart contract is very valuable, especially it will change the entire law in us. It will be, blockchain will be a technology that will change the entire law, basically. The code is the law, that's what they say. But when? We'll see. So the plan is to get to know more about oracles and more about Solidity, so that we can write a contract that gets the data from the oracle and executes the contract. For instance, you are a farmer, coffee bean farmer, and Starbucks makes a deal with you. And in the deal, hey, you say, now it blockchain is everywhere, I want to do a smart contract. And in the smart contract, you add that, hey, if the weather becomes super cold, I will not provide my promise on time, and I will not be penalized for that, right? So the weather became super cold, snow came, and Starbucks is paying you, but you cannot deliver the coffee, right? But you have already a term in the contract. The oracle gets the weather data, and it triggers the contract and say, yeah, the weather was super cold, so the poor farmer is right, not delivering the coffee on time, he will not be penalized. So this is how the oracles work. It gets the real world data, right? And the real world data can be anything a sensor provides. And it goes to the Chainlink network, like a company that provides Oracle. And the Chainlink is also a distributed network, and it provides the data to any smart contract platform. And the smart contract platform basically communicates with other platform if necessary, right? Solidity has a very good documentation. As you can see at the left, there are a bunch of starters at this website, and we will go through together on Discord. It will be a community learning. You need to also put your time on learning Solidity yourself. And Remix is basically where you can write the smart contract. It's a very good website built for you to write a smart contract and compile it and testify. This is the stuff I mentioned to you. All these ones are layer 1 protocols, Avalanche, Polkadot, and on top of level 1, there are all these different protocols. So the actual value is actually at layer one. It's from my perspective, because they are the core providers for any new companies coming into the market. So a very good layer one company will probably overpass Ethereum and like Solana, for instance, or Avalanche. It will be more invaluable at some point. We'll talk more about this at the trading and cryptocurrencies part, which companies are more valuable and what they are doing, right? And those applications can be NFT marketplaces now, music royalties tracking, voting mechanisms, right? Now, maybe in the future, the votings will be done through blockchain. Everybody will have an identity on the blockchain and it will be much more secure, right? And real estate is one of the areas I'm mostly interested. DAOs, we talked about a little bit, decentralized autonomous organization. DAOs will change the way things are working right now. For instance, venture capital, right? When you have a company, go to venture capital and ask for money. Hey, venture capital, I have a very valuable company, give me some pre-seed money. My valuation is 10 million. They say venture capital, I give you 1 million for 10%. So this thing is slowly changing because now companies are getting the monies from people, right? So, and the power of the people to be able to vote, to be able to fund, to be able to talk and basically change things are basically what is behind that. Those are collective power of people, right? Web3, Web1, Web2, now it's Web3. Web3 means peer-to-peer, so no intermediaries. For instance, Brave is one of the basically explorers instead of the Chrome, instead of the Internet Explorer, it's basically peer-to-peer explorers, right? And it was a Web2 architecture before, and there was a browser, there was a web server, you get the data, the web server shows you through the front end what is there at the server, and then everything you do is recorded in the database of that company. Now it is Web3. There is the browser like a Brave browser, and there is a web server which shows you the front end, but now it's not written on the database of that specific company. Now it is written on the blockchain. So your data is not owned by Chrome, is not owned by Firefox, or your transactions for purchases are not known necessarily by Amazon, right? So that's why Web3 architecture, this is a little modified Web3 architecture, which is basically EtherGS and Web3GS is the middle guy between front end and provider, which will go to details further. But basically the idea behind Web3 is that.